towards starting the session. I think if you want to, I just wanted to introduce Trinket as a simple starting point for all of us. But if you want to take it to the next level, it just make a Trinket account. Okay. So you just need to create a simple login and password. It's a free account. You can make a Trinket account. And then if you look at your, okay, so let me officially start the session, right, Manish?
Yes.
Okay, so we are starting today. So first of all, a couple of you had asked this question about how can I save these snippets of code for myself. So I want to say that the simplest thing is you create an account on Trinket. You can go to trinket.io or you can click on this and create your own account. What all of you should be seeing is where I have a save button on my screen. Can everyone see my screen? Can somebody tell me? Yeah, okay. So where I'm pointing at the save button, you should see a button here called remix. Okay, and the idea between remixing is that you can make a clone of the code that I have. And then you can save it, you can make your changes, etc. And the code will stay in the cloud. Okay, so if you want to keep things, this is a quick way for you to keep the code. And then when you log in, if you log into a CATS, you might need an extra one more login into Trinket, but then you can see your versions of the code in this place. Okay, so give it a try. If there's any trouble, you don't have to try it right now, but if there's any trouble, just drop me a note and we can also go through it in detail in the office hours. Okay, so today is a packed session. There's a lot of stuff for me to cover today. So let me just start off by doing a quick recap of last time. Okay, and the recap of last time is we talked about writing functions, using existing functions and writing new functions. Then we talked about decomposing problems into functions, right? So how do we take a big problem and break it down into functions? And then we talked about, of course, a very big subject, but Boolean logic, right? And the introduction for us was fairly simple. We talked about Boolean variables and we talked about operators. Okay, so while we were writing the code, we stumbled into something which I think is a tricky corner in programming languages. So I thought I will reiterate. Huh? Yes, hello?
What? I'm in my online course.
Okay. So I love the live world, right? It's really cool. It makes me nervous sometimes because there's so much I cannot control, but okay. As you can see, it's a nice question to ask where the programmers are very control oriented, right? We tend to think about everything very carefully and we want to control everything, but life we cannot control. Okay, so back to Boolean variables. So the idea is this: whenever we have a type, by type I mean a programming type like integer, bools, etc., we always should be asking the question, how does the type get constructed? And so I'm going to show you this thing explicitly today, that every type has what's called a type constructor, right? So when the people who created, is this font big enough or do you want a larger font here? Maybe I can make it bigger. Font.
Yeah, just make it a bit bigger.
Yeah. Is this better?
No, a little bigger. Yeah, now it's good.
Okay. So I just want to share with all of you that if this thing is getting in your way, you can always drag and move it aside. Okay. And then you can adjust the font if you want a little bit too. So anyway, so the point I wanted to make here is that whenever a type is there, so let's start with integer, for example. So if I have an integer, then normally we just type this way. We just put in the number 5. And Python realizes that you want to create an integer 5. Right? So it's actually when the Python parser runs, it recognizes it's an integer and so if you ask what is the type of a int, it becomes 5. But of course, if you want it to be explicit, you can call the constructor, right? And this constructor or the constructor manufactures the type explicitly. Okay, now you don't need this by default, so we don't use this. But one of the questions that we have to ask when you are writing, if you're a Python developer and you're writing the code for the constructor, we must ask the question, what are the valid inputs to the type constructor? For example, could I pass a string 5 to the integer constructor and ask the integer constructor, I've given you enough information to create the integer 5. It's sitting in a different type right now. Your job is to go to that type and extract the integer 5 out of it and make me an integer. Right? So I want all of you to get this in your thinking patterns, that type constructors also are type converters, and their job is, given some information, build the type of interest. Okay. So in this example, the integer gets manufactured even though I've given it a string. So now we can ask a very interesting question. What does the bool type constructor do? Right? So this keyword bool is supposed to say, please make me a boolean. And what is it supposed to do? So the first thing is, if you look at the bool type constructor, if you give it the value 0, then does anybody want to tell me in chat, what should the value 0 emerge as a bool? Should it become true or should it become false? False. Okay. Yeah, that's correct, right? So it's logical. Somehow 0 is false. Then what should the value 1 produce? So if I replace this with 1, so let me just run that code quickly. So it says, first of all, if I check the type on it, it has produced a bool as required, and the value is false, as we thought it might be, right? So that's the right concept. If I replace this to 1, then it should make true. Okay, so as far as this is concerned, in fact, in some subtle way, the Boolean type is a subset of the integer types, right? Where the integers are the infinite set of integers, the Boolean is only 0 and 1. Now we can ask a different question. Is there a sensible way in which a Boolean is constructed from a string? Okay, and so we have to ask the question, if I have a string like this, what Boolean type should be? Okay, what Boolean type should be here? Anyone on chat? So if you look at line 8, what should get created here? Which type should get created here? Okay, somebody said true, and the answer is yes. It's going to create the type true. Okay, so how does that? So let's just run it and see. It creates the type true. You see on the second line here. So what is the logic here? So what about this one now? If I remove the a and just put a blank string, what should happen? You see, it creates the type false. So the type constructor for bool says, if I have a blank string, I will manufacture false. And if I have any other string, it doesn't really matter. So for example, if I put the string true here, then if it will still create, even though it looks as though it has information to create the type true, it says it's a non-zero string, non-empty string. And so I'm going to manufacture true still. Right? So it's not sensitive to the content of the string. It's only sensitive to the fact that it's non-empty. So you can see why it's a subtle bug, because here I could have written code like this and expected it to create the Boolean type true, but it's not doing that, right? So sorry, Manish, you asked me to make you a co-host, but I think you are already.
Really? Okay.
Yeah. Okay, so hopefully that is clear. Now I just want to show you, therefore, if I use, so when I wrote this previous problem, remember we wrote this problem the other day in class, and I had written here, if it is sunny, please enter true for true and 0 for false. And false for false as strings. But if you enter those strings, then I have to write an explicit converter that takes true and makes the Boolean true. Takes the string true and makes the Boolean true, which we showed in class. But now I'm showing you that, of course, if you want to make a small change to the program, and I want to highlight this idea here, the change to the program is to ask the end user, if you enter 0 and 1, my life gets easy. Because then I can just pass it to bool. First, okay, so let's look at this code. So let me change the program first. By change, I mean change the requirements on the program. If it is sunny, I'm going to ask the user to enter 0 or 1. And if it is cold, I'm going to ask them to enter 0 and 1, not true or false. So now if I want to write that program, so let me just quickly comment out this part of the code. If I want to write that program, my life becomes easier because now the input that comes from the user is easily converted into a Boolean, right? So let me just look at the code here with you. So if you look at this code here, you can see that this, when I write this code, what comes back from the input from the user is going to be 0 or 1. So first that is a string. So I convert it into an integer. And then the Boolean constructor knows how to make true and falses from zeros and ones. So I call the Boolean constructor. And so now if you run this program, it's going to do the right thing. Okay, so is it sunny? So let's say, at least here it is sunny. So I should enter, okay, so notice I have to enter what is requested of me. So if it's sunny and it's true, I have to enter 1. Is it cold? Let's say yes, so I enter 1. And it found the value true for both of them. Okay, and then we did the Boolean logic on it. So we also figured out correctly that Mary is not happy. So please take a minute here. This is all I can say in words, but the idea is very powerful, okay? The idea that we understand the types have to be constructed carefully, especially certain kinds of types, okay? And the bool is one example. And then the second idea here is very, very, very important. See how difficult it is to interact with a user, because they can type any value, you have to check for errors and so on. I have not focused on error handling at this moment, but again, it's a very important concept. Right, so I as we start doing this, we'll spend more and more time writing code, interacting with users, etc., and you will get much more familiar with it. Okay, so quick poll for you. This is kind of a poll from last time. Was it easy for you to understand functions? Are you able to write functions? Can you just quickly take that? 2 quick polls. The first one is about functions, and the second one is about Boolean variables. So I just want to know where all of you are in your practice and familiarity with these topics. So quick poll. I'll give you 1 second or 2 more seconds. I have to say I'm comfortable after all these years. Is everyone done? Okay, I'm going to try. Okay, so some of you need a little more practice. Most of you are comfortable. Clearly, there are no questions. Okay, listen, I'm really trying to force you guys to ask questions if you have them. So it's good to know you don't have questions. But yes, I will repeat this. Even though it's not very glamorous, sitting down and just typing a little bit will ease a lot of problems for us, right? So don't hesitate to, and make sure that it becomes a routine, and discovering the pleasure of writing code is something that would be wonderful for me to know that you have found, right? It takes a little while in the beginning, everything breaks and it's fragile, but soon it will all become nice. And these simple examples are enough. You don't have to write something very sophisticated, although I am going to accelerate our discussions. So of course, if there are questions, keep me slow. So let me just now focus on what we will discuss today. I have a fairly big amount of work to do today. So there are a couple of small ideas related functions that I want to share with you, because I want to use those features. Then we're going to talk about the if branching thing, which we talked about quickly last time in a little bit more detail. Then we'll talk about while loops. And then the last section, which is kind of important, is I'll show you how to test your code. Okay, so let's start quickly with this section. If all of you can go, I think the link will bring you there, but it probably just opens up a new tab. But if all of you can go to the section on functions, which is session 2.1, the section on functions 2.1. And under it, I want you to go to the last tab, additional topics. Okay, I'm going to continue to type for a few more minutes because I just want to get you some information, and then we'll start writing some actual programs, and then maybe I'll pick a volunteer. Okay, so the first idea here is really useful idea. For example, one of the things I like, again, let me just make my font bigger. I like to make sure in my code, as we talked about, interacting with a user can be pretty complicated as your program gets bigger and bigger. So one of the things I like to do is to create a function in my code when I'm writing bigger programs that says, get inputs, right? So this function's job is to go to the user, and then from the user, its job is to get different inputs, right? And the way to get, once you get all the inputs from the user, I would like you to convert it into the right types, deal with errors, all kinds of things, and finally give me the inputs that I can use for my program. Okay, now I want to stress this idea. This kind of decoupling, breaking your problem into two pieces. One piece is responsible for interacting with the user, and another piece is responsible for solving a problem, right? So then that helps us to make our code more modular and sustainable, right? So we don't have to struggle to fix errors. It'll become easier. But one of the requirements of this right now is that this function might get multiple inputs, and I want to return multiple inputs to the rest of my program. So how would I return multiple inputs? And the answer is, you can just return from a function as many parameters, as many values as you like. Okay, you can return as many values. There's still a little noise on the line. I don't know where it's coming from. Is it bothering any of you? Is it coming on your microphones too? Okay, I think I found somebody's got an unmute microphone. Let me see. Okay, give me 1 second. Let me see if I can fix it. Okay, is okay. Microphone's off. Okay, so probably it's better. Okay, so back to functions. So the idea here is this: as many values as you want to return from a function, you can return them. All you have to do is separate them with commas, right? Right now, I've taken the example of getting 2 values back from this function. And also, you see now I made a program here. This program needs to use the get inputs function. So I know right now that get inputs is going to return 2 values. So in my equality thing, I have put 2 variables to catch the 2 values. And these variables have to be in the same order as they're coming back. Okay. So now let's run this program quickly. It's not very complicated. So if you run this quickly, it's actually able to do, get the 2 values for us. Okay, so please play with this. And I'm going to explain this string format in a second. Okay, so let me just talk about one more idea related to functions. Okay, and this idea is also important when you create a function. So let's look at this function. It's supposed to make a multiplication table. Okay, and usually it's nice to write it with a for loop. So I haven't written the whole program. But in order to make a multiplication table, the first question we should ask is, I guess that's what you call it, right? 2 times 2 is 4, 2 times 3 is 6, multiplication table, right? So I want to make a full multiplication table. In order to do this, I need to know the number. So for example, I need to know what is the number I want to make the multiplication table for. And then I guess I learned my multiplication tables up to 12. I was supposed to memorize it up to 12. I don't know whether you guys do 15 or 10, but there's a size of the table, right? So there are 2 parameters I need if I want to make one multiplication table. And it's the idea now that I want to tell you is, normally we would have written just number here saying there's 1 parameter. But what I can do also, and this is very useful in some places, especially when other people are using your programs, is to provide what's called a default value. So I have put number equals 2 and size equals 12. This means that if the user doesn't specify these 2 values, it will default to 2 and 12. Right? So now I give a big programming guideline here. When you write programs, always provide sensible defaults. So that it's easy, especially if you have 10 or 15 parameters of 8 parameters in your function. It's nice for all of them to be defaulted. Now I mentioned this for 2 reasons. The first reason is that many of the programs in Python, which you use, when you use Python functions, they all seem like they have only 1 parameter often. And the reason is because Python has defaulted many parameters. So in order to know which parameters in the functions, when you look at the documentation, you will see this. And the idea that parameters are defaulted, you'll see this equal to in the definition of the functions, in the function signature. Okay. So please go ahead and make sure that that's working for you. But right now, if I run this program, so let me just get rid of, let me just run this program. So this program, notice here, I have created the program on line 15. And all it's doing is taking the two values and printing it out. But what is done here on line 23 is I'm actually invoking the program. And notice that, you know, first I can run this program without specifying anything, right? I could just run it like this. So you see the program actually runs and it prints out the message. And by default, it has used the values 2 and 12. Right? So it's very easy to use this function if you don't even know someone's trying to use it. If you provide default values, they can just use it just like that. Now, if they want to override, suppose they want to do 3 and continue to use the size equals 12, then they can just enter one parameter and it'll work, right? It says 3 here, notice. And if they want to specify 2 parameters, they can specify 2 parameters, right? Instead of 12, let's make it 15. Okay, so these default parameters are really important. Okay, and now the last piece here, these are all tricky things, but useful things in some ways, some sense. The name of the parameter is number. So when I call the function, I can say number equals 3 and size equals 12. So these are keywords I can use. Usually you don't have to do this, it's extra typing, but I can actually specify the keywords. This makes your code a little easier for you to read when you're reading your code. Because if I just wrote 3 and 15, you don't know what is 3 and 15 stand for. When I call the function, if I write number equals 3 and size equals 15, you can read it. There's a tricky thing here I'll mention, but please don't use it. You can change the order of the parameters and it will still work. So you can pass size first and number like next, and it will just work like magic. But of course, changing order of parameters is not recommended, right? I mean, you will eventually make bugs and get confused. Okay, but it's possible. So a couple of important ideas related to functions. Again, just write a few, try it out. It should be fine. If there are any questions, please post in chat. Okay. So that's all I wanted to do in this section. So now we're going to go to section 3. So sorry, not section 3. So we're going to go to this section here. Hopefully all of you can see my screen. It's 2.4, and we are going to do the if statements. So the section 2.4.1, branching with if else.
So John, probably we can take some questions if they have about default parameters. What happens if we write first, like, can you go back to that screen, previous one?
Yes.
There was a number and size. What happens if we write size equal to 3 and number equal to 15? Would it pass it that way?
Yeah. So once you start to specify, okay, so let me just.
Yeah, let's check that part.
Yeah, let's check it. What Manish did is what all of you can do, should do. Interrupt me. It's okay, right? I mean, if it just gives me a clue that I can spend an extra minute on an idea and make sure that it's clear to everyone, okay? Even though there's a lot to cover, there's no point for me to rush through things. So, okay, I'm back here. Thanks, Manish, for the question.
Yeah, so so the parameter order is number and size. When I'm calling the function and I pass size equal to 3 and number equal to 15, what will happen?
No, there are two ideas here. One is, you can change the order. So if I take this value size equals 15, and if I put it first, then it will just work, right? And let's keep the size as 15.
Yes.
So that when we see the output, we see where is it going to go into the string, right? How does Python understand it? And you can see the number is correctly put as 3. And the size is correctly put as 15. Python is not confused. It knows, right? So for example, if you look at my code here, number and size, it goes to the right places. Okay.
Right.
Now, if of course by mistake you put size equals 3 here and hope that Python is going to put 3 in the place of number and so on and put 15 here, it won't flip it around for you, right? It will do the right thing. So let's run this code, and it will make a multiplication table for the number 15, but the table will have only size 3, right? So yeah, so when we change order, just make sure that you're using it the way you want to use it, right? So just make sure that it's used in the right way. Does that answer your question, Manish?
Right.
Yeah.
What happens if you pass it with some other parameter name? Is it like logical binding, or it's binding by the name? Change size to something else.
No. If we say n equals 15, for example,
yes,
it will complete.
And L equal to 3.
Yeah. If you put anything other than it, so the keyword is important, right? It's trying to match it. So, sorry. It's going to actually complain that I don't know what you're talking about. If you just pretend that there are two labels, it's not going to take.
Okay.
Right. So we have to use exactly this thing. Now I'll tell you one more small corner case here.
So this is being different from other programming languages like C++ or C, where you can just like pass with any parameter name, I guess.
Yeah. This, as you can see, calling and using functions is a very important piece, and different people have tried different ideas to make it easier for us to write code. So
I have a comment.
Yes.
Again, Manish, you are getting confused between the name of the parameters and the value that you are passing. You can pass size equal to L if L is a variable. So I can say n equal to 20 and then say number equal to n.
Okay.
So that is possible.
Okay. Is this what you're thinking of, Manish? Something like that.
Yeah. No, that's okay.
Yeah.
Right.
So this is possible.
That's possible. Right.
Keyword says that on left hand side of this equal, you should have a name which is already occurring in the parameter list. But right hand side can be any value.
So my question, Amay, was that when I'm declaring a function, like with def, right?
Yes.
I use two labels, number and size, right?
Yes.
And when I'm calling a function, I can use any other label, but the keyword you're saying to the left has to be the same. But
has to be the same, one of the parameters in the function definition.
But if I remove size equal to, just pass L and L, that will work.
Then it will work, but the binding will be according to the order. So L will go to number and N will go to the size. Okay.
Oh, yeah. Okay. So let me just do that example quickly. Size is 12. Okay. And number is 3. And here, of course, you cannot change any order or anything. If you want to just use this, you can. Of course, this is the normal function invocation, right? Nothing new here. You just do s comma n. Sorry, n comma s.
Yes. So this is
the order is important here.
Okay.
Now the order is important.
Okay. So thank you. That's important because if you're calling with keyword, you have to. It will go as per the function definition. Okay.
Yes. If you are not calling with keyword, then it is order.
Okay.
Okay. And you can mix things. The worst will be you define size equal to 12 on line 23, number equal to 3 on line 24, and then call make multiplication table size comma number. Right. Now the size on line 23 will go inside function as number. That's the most confusing. I think that's what BJ wants to avoid.
Yes, I want. Yeah, exactly. So remember that when they give us flexibility, we should try not to get ourselves too sophisticated and make mistakes. Yes. So keep it simple. So let me just recap again quickly. These things are variables. Call them what you want, right? These things are parameters in the function definition. They have standard names, which are part of the function definition. And now we have this extra capability that we can actually use keywords here, right? And once you start using keywords, you can change the order if you want. So the first reason to start using keywords, I think, is to make your code more readable to you. If you think that this is more readable, then you can put an extra little annotation for yourself. That is the first reason, right?
And one more point. So Python, once you go to this machine learning kind of or analytics libraries, functions will have 20, 30 parameters.
Correct.
Okay.
Correct.
In which case you just want to pass 2 out of these 30 parameters. Others you want to keep default. At that point, keyword parameters become very, very important.
Correct.
Because you want to tell that whether you are passing some threshold or are you passing some variables value and so on. Okay, so it becomes self-documenting code. And you don't have to remember all 20 parameter names, just 2 or 3 which are most important for you.
Correct. So that again, as Amay was saying, it's a little bit early for us to look at complicated functions, but even the print function has multiple arguments. So if a function has multiple parameters in it, then this way you can be explicit about which parameters you want to use. Okay. So there are a couple more comments I can make, but I will wait for questions from you at some later point. But at least start thinking about default values where we preset values on your function. And then start thinking about whether you want to use name parameters now. Maybe you don't need it right now, but as we go towards data science and more complicated functions, it will definitely become useful.
Yeah. Yeah, on a simple thing, like a simple function like make multiplication table, there can be like a deep discussion like this.
Yes.
Yes.
No, so no, that's the whole point about asking questions and the idea, right? That of course it's a simple thing, but there are some bigger and bigger ideas here. And I cannot stress enough that functions are the bread and butter for most of our programming languages in some deep ways, right? They're little blocks of functionality. And so all these ideas have been tried over time to make them more flexible and more usable and so on. Okay. So yeah, just write code, questions will come, please come back and discuss it. Okay. So now the next thing I wanted to say is, let's go to the next section, I guess. And we'll start on if statements. So if all of you can find our way back here. So section 2.4, and we'll just spend a minute on if statements. By the way, if statements in some sense have become kind of the building block of most programs we write. Many programs, much of the logic in your programs can end up in if statements. And as a starting developer, it's like finding a hammer and everything looks like a nail. A lot of your code can and will end up in if statements, and some of it in loop. But eventually you'll see that complex if statements, even today we'll write a little bit of code on this, complex if statements can make your life a little difficult. Okay, so let's start off by saying what is an if statement do? Simple. So here's the mental picture. If some condition is met, you do some action. Otherwise, you do another action. Right? Now, I will just call your attention to the white space here. The if statement has to be ended with a colon, and then all of the instructions that have to be performed if this condition is true has to be all at the same level of indent. Then there's an else statement which ends with a colon, and all of the instructions here have to be at the same level of indent. Okay, so now traditionally, or in the old days when people were actually working with pen and paper and drawing pictures to represent the if statement, they used to draw pictures that look like this. I don't know if you've had any course in logic or programming that required you to draw these pictures, but it's a good thing to look at this picture once, right? So the idea is that as a program comes in, then you can think of a branching point here, right? Where the if condition gets tested. And if the if condition is true, then all of the code that's in the left side, I just put it visually as if the world's kind of interesting picture, right? The world splits into two pieces. And in programming, only if the condition is true, then only this part of the world exists. The other part of the world doesn't get created, right? So we branch into two pieces. And then after we exit the if statement, that means after you finish this part of the code, then the program continues as if the branch never happened, right? I mean, it remembers whatever the branch did, but it becomes single branch and continues like this. Okay, so it's like for a small period of time, it's as if the world splits into multiple pieces. Okay, I say multiple pieces, right now only two pieces, but I said multiple pieces because I am presuming that we're going to discuss this other construction, which is the same, but now I can make multiple branches, right? So there's an if, there's condition 1, then notice this is elif, not else if, and there's condition 2, and then there's an else, and some other code. In this case, there are 3 branches, okay? And I'll just make one quick comment here. The number of branches in your code is clearly increasing the complexity of your code, because now you have to imagine 3 different worlds and make sure that in each world, the right behavior is being implemented, okay? Okay, so but clearly you can write as many branches as you want, and later, very much later in the code, I'll show you how when you have too many branches, maybe you want other strategies. But I'm not going to discuss strategies for eliminating them. We're just going to start writing if statements now. Now, just because I said there are different branches, I want to just show you this little piece of code here. So let's say I declared a variable x equals 5. ignore the second variable. I'm not going to use it right now. X equals 5. And then I'm going to test it. And the condition that I'm testing is x less than 4. So let's see what happens when Python runs it. It creates this variable x equals and label x and gives it the value 5. Now it's going to go towards the if statement, right? Of course, the other variable also gets created, but it goes to the if statement. And in the if statement, it's checking is x less than 4, which is not true. So it's going to skip over it. You see how it jumped? And the green line shows where the test started and then skipped over here. Now it's checking is x equals 4, right? And it's not true either. So it skips over. And now it's going to execute the code inside the last part, which is the else statement. Okay, so again, it's nice for you to have this visual model of Python trying to enter each of these branches and then making the decision which branch to enter. Okay. One thing I will mention now, you will experience more with practice, is when you start making branches like this, it's very important what, so the x can take values from 0 to n, 0 to infinity, let's say. We are now splitting that up into pieces. And what happens at the boundary of these splits is important. And by boundary of these splits, I mean, do you do less than equal to, etc. Right? So how you write this condition is kind of delicate. It's a place where a lot of bugs will hide. You write less than, but you meant to write less than equals or something else. Okay, so just pay attention to how the world is getting split. And make sure there are no gaps in your conditions, etc. Right? But with practice, that will become second nature, but I just want to call it out. There are a few questions and things to check. Okay, so I need someone to write some code. So who's going to write code with me today? Someone in chat? Okay, go on. So I will stop share. And if you can share your screen. Don't, to those who have not volunteered right now, don't hesitate, okay? It's probably helpful to write the code in class. You will get special attention, and mistakes are fine. We all make mistakes, okay? So don't worry. In fact, last time we were able to learn some important ideas from some of the bugs, right? So don't, I think there's no bad thing there. So were you able to share your screen? I think William was trying to do it. William B. Yeah, there you go. Okay, so we have screen share now. So William, if you go to the if you go to the page, 2.42. This is the next section, I think. Maybe this next section. Yeah. So let's try to write the simple code, right? It's not very complicated. So what are we supposed to do? We are supposed to just read up the, yeah, perfect, wonderful. We become an expert at this now. William, you can also drag that perpendicular line to the right a little bit. Yeah. Okay, so we're going to write this code, and what is it asking us to do? It's saying there are three variables, right? So it's getting a temperature, and then it says there's a cold limit and a hot limit, right? And there's a condition related to the cold limit, and there's a condition related to the hot limit. So why don't we make two variables, cold limit and hot limit? Okay, as we write this code, I want to tell you there's no single way to do this, right? It's multiple ways. Yeah. And we have to make a decision about these variables, right? Are they global variables or variables inside a function? And let's try to practice this idea. Let's put them inside a function. So delete the pass and then just move this up and then indent it. Okay. Okay, so there's hot limit and cold limit, and let's put some value. William, when do you think it's too hot? Okay. Yeah, we're gonna have huge problems because we think in Fahrenheit, but that's great. I'm like, that's too cold. Okay, but okay. No, that's great. Cold limit. So when do we think it's too cold? Wow. Okay. Really? Pretend this is a thermostat in your house. Like, what's the cold limit? When you don't want to go below some number, what number do you want inside your house? Okay, better. Okay, good. So all of you can. No, this is a silly little program, but I want you to understand this is the kind of logic that's inside a. If you had a clever thermostat, then we could ask the user when do you feel cold and when do you feel hot, and then we could have a thermostat that automatically regulates the temperature for you. And this would be the logic in that thermostat, for example. Okay, so we have a hot limit and a cold limit. Later, you guys can make this program even more powerful. You can get an input from the user to tell you what is the hot limit and what is the cold limit. But for now, we've just put it as variables. Okay, so now let's write the if statement. So you say if. So now what is the condition we need? Yeah. Okay, so one thing, William, as I write this, I would say always start on one side of the range and go to the other side. So you can start at high and go to low, but usually I like to go ascending. So if temperature, so start with the cold side first. If temperature is what? Is it, yeah? Okay, just read the instruction and see what is it saying. What message do I have to, when do I have to print a message? If temperature is what? If temperature is less than, yeah. Okay, good. So please notice that this code is like it's written in language. Right? If temperature is less than code limit, that's what we would say in English. So getting your code to look like this is kind of good. Yeah, you can put down, yeah, or you can copy the message from up. It doesn't matter. But let's just for good practice, let's include the temperature there. So how will I, in the print message, how will I include the temperature? Yeah, you put a plus, but I put it at the end. Plus, yeah, and now we need the temperature. Can you do that? Yeah, you have to do something more. Okay, plus, okay, whatever, make some, okay, just leave the temperature there, that's fine. You should, no, that's fine. No, just delete it. Just, I was going to say it is, maybe in between you can put where it is, the temperature is before the, yeah. The temperature is, yeah. Notice how fiddly communicating with the user is. I cannot stress it enough, okay? The temperature is space str temperature. Careful, there's spelling, there's a spelling, temper, yeah. Okay. Okay, that's fine. It'll complain later if necessary. Okay, so we got one part. Now, how many branches do we need? 3, seems like we need 3 branches, yeah? If it's less than cold limit, between cold and hot, and then greater than hot. So then okay, so it's a tricky one. I'm going to write the code this way, and then you guys can write it in different ways. So I will handle the greater than hot case. So if temperature, LF, temperature greater than hot limit, and then you print some other message here now. Careful, it's hot underscore limit. Yeah, and then you print another message here. Okay. 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 Don't even bother about adding the temperature and so on. You can do that in your own time. Okay. So we got another branch. Okay. And the last one, then if neither of these conditions are met, yeah, else colon. then you can write one more message. Okay. So now you can run it. I think this program should work, unless there are some hidden bugs. Notice I've helpfully put some input. Yeah, please click on the right. Yeah, click on the right and enter a temperature. Okay, so we get something. Okay. So take a moment. These are simple programs, but hopefully there's enough for you to get comfortable with a if statement, multiple branches, etc. Right, and then you can improve the messaging and all that stuff and make it good. Careful, you deleted it. Control Z. Yeah. Okay, so let's go to the next section. If you guys have any questions, post them in chat. I am not looking at chat this second. So, Manish, are you looking at chat a little bit? Oh no. Okay, I will. Yeah. Okay, so let's go to the next section. Okay, this one is just another exercise. It's supposed to give you a little bit more help in getting familiar. I could actually defer this as something that all of you do later. So, but at least read it. See if it looks easy, too easy, or too hard, or what is it? Tell me something about it. Someone in chat. Does it look easy? Do you want us to write this program in class, or you got it? Okay, I will make a quick executive decision. Okay, this is easy to write. Please do, and then if not, we can discuss this in office hours, etc. But before we leave this page, I want to show you an important, very important trick here. If you look at this idea, a lot of our code now becomes, how can I construct strings to present information to the user? And we've been doing one technique, which is adding, putting plus and then converting everything to strings, etc. So if you go to this section, Will, can you just highlight that string.format just above the code window? Yeah, this section, if you just read this carefully, there's a new idea here. Maybe hard to read with the highlight, but now we can take it off, I guess. Yeah, so the idea here is this. So we'll type, go to line 6, Will. If you look at line 6, you see the idea is that you type a message here. So this code is supposed to, if you give a score, it's supposed to convert it into a letter grade, right? And the idea here was to send a message to the user, which says, what is your letter grade? The letter grade that corresponds to the score 53 is A or something, whatever, right? So you want to pass the letter grade converted to the user. So the mental picture here is we need a string which has some English in it, but in between, there are slots where we want values of variables to be inserted. Okay, and what we have this construct in Python, which says, just go ahead and type out the string as you like it. Write a sentence as you would in English. Wherever a variable is required, just put a curly bracket. Okay, and then at the end of the string, you put a dot format, and inside the format, you put a bracket, and you pass all the variables that you want to go inside the string. And what Python does is it comes along and it finds the value of this variable at the time it's being run and inserts it into the string in different places. Okay, so I will use this dot format a lot. Okay, there are other tricks like this, and then you can decide whether you want to do the plus and convert everything little by little, or it's nice to write this whole structure and then have the values inserted. Okay, and there are a couple more strings with tricks with format that I can go into, but I won't do right now. Maybe this is just a simple blueprint you can use when you want to construct messages. Type out the message, put curly braces where variables are needed to be inserted, and then in the format, you specify them in the order that you want. There are tricks like changing the order and so on, but it just makes your head hurt right now. You're learning something new. Just use them in the same order as they are put into the dot format. Okay. If there are any questions about this, this is going to be a workhorse for us. We're going to use this a lot. Yes, I think Will said that you can practice writing this code on your own. So please go ahead and do it. The main point I want to tell you is this code illustrates, these two codes illustrate half an idea, right? It's mildly interesting. But notice how this code gets really complicated. How many branches are there in this code? Right? A simple code to convert a grade to a score, if retained with if statements, has so many branches in there. And so it's easy for you to make a mistake when you want to put a less than or a less than equal to, etc. And if you make a mistake, Python will do some strange things, right? So please get familiar with writing this code. I don't need to spend more time unless you have questions. So and make sure you write this code, okay? Okay, so quick, can we go quickly and take this poll? Yes. Okay, so can everybody, this is a little bit of thinking for you now that we think we understand if statements. Can we figure out just take a moment and read the code, right? There's an if statement here. And the question is, what will the program output? Okay. I think most of you got it, right? Or how many? 4 of you. Okay, so we're going to wait for another second. Okay, everybody's seen the answers, okay? So, okay, fine. Can we do the, are you comfortable? Okay, so looks like most of you are comfortable as well. So let's keep going. Great, wonderful. So we're done with if statements. No questions here. Now let's go to loops, which will be the next section, Will. Okay, so again, a big workhorse for us. We're going to see 2 kinds of loops today, for loops and while loops. So the thing that I want to say is, first of all, before we get deeper into loops, I want to introduce a concept here that when you want to loop, you are basically saying that you want to write code that allows you to go over a set of values. And in Python, so you have to specify what that set of values is. And Python has this very nice function called range, which helps us to make these sets of values, these collections of values that you want to loop over, which is also called the loop variable, very easy to create. And so the simplest idea is there's call this function range, and you give it one number. Okay, but actually, if you read what I have written there, you can see it has 3 parameters. And I like to always, all of you think of it, at least in the initial days, in terms of I think of it like a poem. Range has a start, a stop, and a step. So the start value for range by default, as we talked about default parameters, the start value for range is always 0. Okay, and it's defaulted to 0. So if you don't specify a start value, it's always taken as 0. The value that you, then put, okay, that's the first parameter. Take the 5 and put it, no, take the 5 and put it on the right. Yeah, the second parameter is stop. Yeah, and then the last one is step. Okay, so yeah, so just run it now. Yeah, I don't know. I don't think Python takes. Just take off the start equals right now, Will. Just put 0, 5. Yeah, just run it. Indent the print. Yeah, hit run. Yeah, so you get it. So it starts from 0. Notice that it goes to 1 less than the stop. These are all places where there are easy bugs in code. So it starts at the start value. It stops 1 less than the stop value. So if you want it to go up to 5, you have to put 6 there. So a lot of bugs in programs are because of where the ending value is chosen. And the last one is in how many, in steps of 1 it goes. If you want to go in steps of 5, you'll get only integers. Yeah, 2. Okay. Now this is even more clever. It can go backwards and so on. But for a first, so you can put -1. Put -1. Let's just do that one example. Instead of 2, you put -1. And but now be careful. If you run this, do you think it'll work? No, because it starts from 0 and it's trying to go to in the wrong direction. So you have to start with the biggest value, 6. Start with 6 and go to 0. Yeah. Yeah. Well, you don't need to highlight the code. It will run the whole thing when you run. Okay. But hopefully this is clear. As you can see, there are a lot of tricks you can do with loops. Okay, going steps of 2 and steps of 3 going backwards, all kinds of ideas. So please play with it and then of course come back with questions. Okay. Yeah. So what's the message you get, Will? Can you scroll down and show everyone the error message? Yeah, start must be an integer. Okay. Okay. Quickly, let's just run the demo that's below, if you don't mind. If you scroll down. Yeah, just hit the back arrow. Yeah, okay. Yeah, so it comes in. It has, yeah, hit forward now. So the value I is 0 now. Then it goes to the range. Yeah, hit forward. It goes to the range object. It gets the next value. And it keeps on looping, right? So this is what it's doing. So you should have this mental picture of the loop just going round and round and round this way. Okay. So that's all we need to do here for now. If you go to the next section, yeah, so this thinking pattern is probably helpful. All of you read this in your own time and absorb it the way you like to. But the pattern that I want you to have is, if you need to repeat an action multiple times, and if you know how many times you need to repeat the action, then you have to ask the question, what kind of steps do I need to take when I'm repeating it? And then what do I need to do in each step? Okay, and the template is exactly what I have written here. So the thinking pattern is, ask all these questions. Once you have the answer to these questions, then you can start writing a loop. For I in range, you plug in the values start, stop, and step, and then you have whatever action you need to perform. Okay, so I think we can go to the next section maybe. Okay, so there must be a little code for us to write. I try to keep this as interactive as possible. So can all of you try to quickly do this one? Just maybe odd numbers from 0 to 10. So Will, one quick thing, you don't need, yeah, let's do it inside a for loop. So start by writing the for loop. For, yeah, you can start typing for I in range. Okay, now we have to construct the range. What is the start value? Yeah, yeah. What is the stop value? Good. And then what is the step? Even numbers. Yeah. So just try running it. Oh, sorry, there's got to be a colon. I'm sorry. There's got to be a colon. And then you have to print something, right? So you put enter. Yeah, indent has to be there. And print. Carefully, you got caps lock on it. Yeah, print. Yeah. Yeah, just print I for now. Later you can construct messages and so on. Yeah. Okay, so you got even numbers. What about multiples of 5 in descending order? Little bit more tricky. Careful, you got caps lock. Yeah, then you need a colon. Yeah, and then print. Okay, so hopefully all of you are writing this while we do, but if you haven't written it, make sure you do it when you practice, okay? So that's it. So now quick question, just to make sure we all understand loops. Okay, can you go to the next section? Yeah. Okay, mildly tricky question, okay? I don't know. So just read it carefully. It's combining now. We've combined a loop and an if statement. So does everybody understand this percent symbol? The percent symbol is looking for the remainder, right? So if I do 10% 5, it will give 0. If I do 6% 5, it will give 1. Okay, so it gives the remainder after dividing by the corresponding number. Is this question easy? I see Will is smiling. He's like, oh my God, do I have to figure this out? It's okay, you can guess then. We can look at the options and guess. If you want me to talk you through it, okay, why don't you guys guess and then I'll talk you through it. We'll see what people get and then see if my comments make it better. Okay. Okay, so it's divided, right? It's divided. Okay, so the way to reason about this, I just want to talk about the way to reason about this. Remember, all of you can copy paste this in a window and run it and see what happens, okay? But what I want you to see is, first of all, the range. It starts from 0, and does it include 25 or does it not include 25? It does not include 25. It goes only up to 24, right? Is that clear? Because it always goes to the stop minus 1, okay? Then the next thing is it comes, so each time it's going through, it's going to print only if it's divisible by 5 or divisible by 20. These are the only two conditions in which printing is happening. So the only numbers that get displayed are multiples of 5 and multiples of 20. So which are the multiples of 5 and which are the multiples of 20? And notice it's two if statements. So if the condition is satisfied, it's going to print. So for example, the number 20 will get printed twice because it's a multiple of 5 and it's a multiple of 20. Okay, so that gives you a clue. And then of course, most of you are in the right track. Some of you guessed. Okay, but it's okay. There's nothing cool about this. Okay, just go ahead and run it, get familiar with these ideas, and you'll be fine. Okay, so let's go to the next section. Okay, so this is a cool one. We already talked about this. Let me ask this question. This is only to help you to write a for loop. Do you want to write it, or can you take it as practice? We have plenty of interesting things coming up, so I can go either way. Someone on chat? Practice. Which says practice? Okay. By the way, the first person who's speaking up, okay, a couple of you, yeah, okay, practice. So done, practice. Please do write it though, okay? Silly programs, but please write it. Okay, next question. Do we have the next question now? Okay, so the next one is just a piece of information for us. So now there's another kind of loop, which is called the while loop. And I have to share with you that when I learned programming, I was always asking this question, why do I have two looping constructs? And I came up with an answer for myself, which satisfied myself later only. So I never used while loops for a long time. And the idea is that many while loops can be converted into for loops. But there is one situation which seems tailored for a while loop, is when the length of the loop is indeterminate. Up front, I cannot decide, am I looping 10 times or 50 times? So let me just make up a simple example for you to consider. Suppose I want to go to the user and ask for student grades, right? So I'm saying enter the next grade, enter the next grade. It's a loop. I'm going to keep on asking him to enter grades until he says I'm done. So when he's done, he's going to enter D for done, right? So a priori, I don't know when to stop. But I know there's a condition. When that condition is met, I can stop. And that condition may be user triggered or whatever. It can be triggered by various things. So those kind of situations are well tailored for while loops, where the condition is not like take 5 steps. But of course, if you want to take 5 steps, you can write it as a while loop as well. The thing with the while loop is then you have to explicitly make sure you manage the loop counter and so on. We'll discuss this in great detail. So what is the thinking pattern for using when deciding when to use a while loop is, you have to ask, do I need to repeat an action multiple times? Sure. If the answer is yes, it could have been a for, it could have been a while. But is the loop possibly infinite or until some condition is met? That makes us lock into the while loop. Then again, you can ask what kind of steps do I need and what do I need to do in each step. Okay, and then the general template is here. And it's nice to think about it the way I have written it, which is you do while, pretend that the complex condition is there, is inside some function. That function will tell me when to stop. So a lot of people write some Boolean expressions for while, but I like us to imagine we're going to write more complicated programs, take that entire condition and put it into a function. Then you don't have to worry about the logic that determines when to stop. And then you have another function that performs the action. Okay, so it's fairly simple. So quickly, can we write some while loop? Oh yeah, in fact, the code is there. So can we just look at it? So this is a simple counter control repetition. This is not necessarily, yeah. So this I'm doing a while loop, which goes up to 10, right? Up to counters less than 10. So up to 9, okay? So this is an example of where I could have done it easily with a for loop. But I just want to show you how I've taken the condition and put it into a function. And then the while loop has a simple print statement. But notice the counter will not change unless I change it. So every time I have the last line on line 10 is really important. That this counter variable that's eventually going to determine the loop has to stop has to be incremented. This is a very common bug in while loops. This incrementing the counter can get messed up for various reasons. And then your while loop just becomes infinite and crashes your program and so on, right? So simple pattern, if you follow these patterns are here so that they help us not to make mistakes, right? If you follow this pattern, you'll know that at the end of the while loop, I have to do something with my counter. Okay, and then you can run it and it'll work and hopefully all those things are nice, yeah. So please play with these counters. Try to do simple examples of making the counters go backwards, forwards, jump by steps of 2, various things you can do. Okay, you don't have to do it right now. Let's go off to the next section. Okay, there's one key poll in the next section. We're assuming that you're all while loop masters by now. Okay, so some of you have some questions. I don't think I need to spend a lot of words here to explain it. The best way, of course, I want to share with you is put it in the window and run the code, right? That's why we're doing programming, is to run everything and understand. But these kind of questions are just there to provoke you to think for a second. It is nice to be able to reason about it in our heads. So I'm not a big fan of giving a lot of quizzes where you have to reason in your head. The only reason I force that in some places is because, at least in the beginning, it's nice to have the ability to figure out how a program runs in our heads. Prevents us from creating bugs as we type, right? So it's nice to develop the skill, but I don't want to overdo it. The best thing to do in these kind of situations, paste it. Whenever I've taken courses or written some things, I'm like, you know, I'm not going to do it in my head. I'll just run it. So that's also fine. But in the beginning, spend a little time to develop the skill of being able to reason about it. Okay, let's go to the next section. Okay, so now I'm going to tell you something. In some of the courses I've done, I've spent a little time writing computer games, small games, right? Designing and writing them. But I want to share with you that the while loop, there's a very beautiful idea that we can take the while loop and pretend that almost every program we write could have this simple structure. A program that interacts, for example, with a user. So you have a setup that goes to the user, asks him for his login or password or avatar or whatever you want. Then there is a while loop. We can call the main loop or the game loop, right? The loop that keeps the program alive. And this is where this complex condition comes. When to quit the game could be all kinds of things. The user clicks a button, the game is over. There's various reasons to terminate. So there could be complex condition which determines whether the program continues. And then I'm trying to be a little facetious here by suggesting that every program is just make a next step. Right? You're listening for inputs and you make a next step. And then you keep on looping like this until the continue program says don't continue anymore, and then you just end the program. Okay, so I want to suggest to you that this simple pattern can be used to do all kinds of interesting things. I haven't given you an exercise to do this, but if you want, I can write up an exercise for you to write a simple computer game or something like this. 20 questions or hangman or something, okay? Okay, so let's click on the next one. Okay, but somehow I'm getting the impression that you are much more serious folks, so no computer games for you. If you want games, you have to ask, okay? But because you're much more serious folks, I will show you another interesting idea here, right? Which is how to find square roots of a function, okay? The idea is mildly complex because I don't know what does, I guess because you guys are not a microphone, but I'll still ask and see if somebody wants to answer. How do you find the square root of a number? Did they teach you some algorithm or tell you how to compute the square root of a number? Anyone? Please turn on your microphone and give me something. I will take silence to mean people are like, oh no, that was in math class, I've forgotten. But Okay, so what I wanted to say to you is, since I'm not getting any responses, I'm talking, okay? Maybe I should be quiet. Okay, I will try. 3 seconds. 1,000, 2, 1,000, 3, 1,000. No, okay. Okay, so let me just say that this is a beautiful example of something we could have done even in math class, even at a young age, preferably with a computer language, but we could have done this on paper too, right? Which is to discover that we can solve certain problems by iterative procedures. So first, let's start off by asking the question, how can we find square roots of integers? So that will be the first program we write, right? And the answer to find the square root of an integer is, you can just start with 0, right? So let's look up a number. Sorry, square root of 4. 0 squared is 0. So then I go to 1. 1 squared is 1. It's not yet 4. 2 squared is 4. It is the square root. We're done. Right? So this becomes a very beautiful metaphor for iterative searching. Right? We know the solutions of square roots of integers lies in the integers. So we have to just explore all the integers. See how computers have given us a new way to find solutions. As long as we have a valid question and we know the answers lie in some range, we don't need a clever procedure. We can just go through the range and just by brute force find it. Okay, I'm going to show you later that brute force doesn't work always, but it's a great place to start, right? Just brute force it. So why don't we go and write this program? And this program I also want to show you is a metaphor for how do we write everything using functions, etc. So let me just talk you through some of the ideas we can use to write this program. So the first idea is, if I'm going to iterate, I just start with a beginning guess. So my beginning guess could be 0. But then I want to take a step to explore the space I'm in. So my step size could be 1. So I'm going to explore the space in steps of size 1. So I've written a little function that says improve the guess. Right? And in this case, if you give me, it doesn't depend on the value x. So I could have removed it as a parameter, but there are some improve guess algorithms that depend on x. This one doesn't depend on x. Simply takes my current guess, my current value, and just adds a fixed step size to it. So that function is a very easy function to write, right? Simple function. I will just give me a current value. The next value will be one step. Let's say we're going in ascending order, one step away, one step higher from it. The next one is a little tricky one, but very important. When do I stop? I'm exploring for a solution. When do I stop? And the answer is, I will take, so look, I'm trying to find a square of a number. So the guess, I take the guess and I square it. So for example, I do 1 squared, I get 1. The number I'm trying to find the square root is 4. So I subtract from 4. So this number will be some number, right? And I want to stop when this number becomes 0, right? So my tolerance in this case is actually 0. If the difference between my guess squared and the answer is 0, then I can stop. Okay, so as I'm writing this program, I want you guys to understand how the problem is decomposed in little pieces. Each piece can be very clear and easy for us to understand. When shall I stop? Well, I will take my current guess, I will square it, I will subtract it from the answer. And if I'm close enough to the answer, then I can stop. Okay, notice this thinking goes from the precise case where we're doing integer square roots to when we do non-integer square roots as well. So that's why this program has to be written in this way, okay? And then that's it. Let's go write this program. So, Bill, I think there should be a page for you to write below. Yeah. So let's just go and start writing this program. So we said we already, you have the code upstairs. You can copy it. Yeah. By the way, I'm completely okay for you guys to copy, but I definitely want you to keep it in your head, reason about it. Okay. Guess equals. So yeah, we are updating guess equals guess plus step size. Oh, okay. Guess plus step size is enough. Then return it. Yeah, that's fine. Yeah. Okay. Now a stop condition. So again, yeah, you're going to return something. Yeah. And what are we going to return? So we're going to take the value x. Yeah. Take the value x. You're going to subtract your guess squared from it. right? Okay. And then you're checking if it's greater than tolerance. Okay. Now, quick question. Do we need brackets here or not? Should there be a bracket? Should there be a bracket or not? Okay. When in doubt, put the brackets. Okay. If you want to become a Jedi programmer, no, the bracket should be, yeah, I can see. The font is a little small. Yeah. Yeah, that's good. No, you don't need the bigger bracket. You just need the inner x minus k squared. Okay, that's all good. Okay, so like I said, when in doubt, use brackets. Okay, it'll prevent you from having problems. But when you want to ask, do I need a particular bracket? Go and test it out carefully. Okay, just remove the bracket and see what happens. Think about operator precedence that can help you. Okay, so okay, and are we done? What else do we need? So inside the while loop, there's a pass. Inside the while loop, what do we have to do inside? Yeah, we're writing this function. So we start with guess equals 0. There's a step counter which we can use. I want to know how many steps it takes me to find the answer. Okay, and then there's a while. We've already written the stop condition function. So now we have to go inside the while loop. And here we have to update. Basically, we have to update our guess, right? So start with guess equals. And it's very nice, improved guess. Yeah, improved guess. Okay, and then just pass the parameters. Yeah.
So Christian is asking to increase the text size.
Font size. Thank you. Yeah, well, we have to all remember. Yes. Okay, so we got it. So guesses, we are going to improve the guess. Okay, and then we have to, important thing, what's the last thing we have to do in any while loop? What's our loop counter? So it's very interesting, right? We don't need a loop counter at all here, because we'll keep on looping until the step condition is met. Okay, but I wanted to count how many steps are there. So I have to increase my step count, which is not my loop counter. So write step count, step underscore count, just a variable. I want to track how many steps it takes to find the answer. Step count plus equals 1. That increments the step count by 1. And then once we exit the while loop, I will return 2 values now from this function. It will return the final guess and the final step count. Okay. So, okay, so then below you can read the code which is written below that's the function to run this whole thing. And it's basically, you know, it's picking an X, a tolerance and a step size. And then it's going to find the square root using those 3 parameters, right? And then print out the answer in a nice format. So please, we've used the string.format. format. Notice it prints out a message for you. So I would ask all of you to, of course, run it now. So let's look for the square root of 4 first. Okay, it's going, just do 4. Yeah, always start with a small number so we can reason about it. Yeah. Yeah, the square root of 4 is 2. The step count is 3, right? 0, 1, 2. Okay, and then there's no error in this case. Okay, etc. Okay, so you can play with this program. Now, immediately I have to tell you, because we wrote the program this way, the first thing you can do is you can ask the question, what if I want to find the square root of 2? And by the way, it's one of my favorite subjects to talk about in a class like this, but I cannot indulge. Square root of 2 is a beautiful thing, okay? Because it's the first time we recognized that a number can be a number, not a fraction. Right? It's a little bit of a shock that there are numbers that are not fractions. So the mathematicians of, let's say, ancient times, 300 BC, I like to think about this number. That's the height of the Greek mathematical school, right? And I want you guys to think that there were people in 300 BC who were asking these kind of questions about numbers. Are there numbers that are not fractions and so on? Okay. So Will is trying to make this work for 2. Okay, to find the square root of 2. This is not going to work, right? Why is it not going to work? Because we have taken integer steps. So you have to take non-integer steps. I don't want you to write this program here now. Before you change this program, I want you to spend 5 minutes and think about exploring the space of real numbers, which is very fine space, right? So you can go in steps that are non-integer steps, then only you can explore the space of real numbers. So your step size must become a number like 0.1 or 0.01. And when your step size becomes a non-integer, then your tolerance also has to be kind of calibrated to be related to your step size. Okay. So I would encourage all of you to play with this. Make sure that you Will, quickly, can I just ask you to show, if you go up, I want to just show you some of the instructions I've given on top. By the way, there's a lot of code here for you to look at. Okay, so if you guys want help along the way, there's code to help you. But if you scroll down there, Will, just a little bit below, if you hit Control plus, your screen will become bigger. The font will become, I believe, oh, you're on a Windows machine now. I'm on Linux. Okay, okay, you can next time. Yeah, that's good. Yeah, one more. Yeah. Okay, perfect. By the way, this gives me a moment to talk about this. When I'm on I have worked on Macs, Windows, and Linux. When you're on the corresponding platform, take a few minutes to master all of the keyboard shortcuts. They're tremendous time-saving things. Then imagine your life is dribbling away every time you click on drop-downs and search for menu items and so on. So invest time on practice all those things. Okay. So, but I want to now draw your attention to an important thing here. That if you scroll down, first of all, you look at this. Sorry, a little bit up. Sorry. I've asked all these questions. Will this method work for irrational roots? Irrational roots are like square root of 2. Okay, and then you have to answer all those questions. How do we choose the tolerance? How many steps will it take? And of course, we can ask, is there a better way to compute the square root? So the first way which we want to use to compute irrational roots is to go in steps of 0.1 or 0.01 or something. Okay, and just explore. Now, I don't know if all of you have memorized, but I certainly memorized a long time ago. Square root of 2 is a number like 1.414. Okay, so it's a decimal number. It's less than 1.5. So if you go in steps of 0.1, you know that you don't need, like if you want to get to 1 decimal place accuracy, you need only 4 steps. 0.4. Yeah. So figure it out. Spend some time, reason about it. Take a piece of paper. I am trying to get you excited and interested in this tricky ways of solving simple problems, but in an explicit way using a program. And part of it is just exploring. Like, I don't know why in 6th grade or 5th grade, when they showed me square root of 2, I didn't do an iterative search. My teacher didn't say search iteratively, you can find it. And they gave me something to do and I did something else and I didn't learn anything. But what we are learning today is a very powerful solution. So when you come to machine learning and so on, one of the coolest things you can do is to ask me, can I solve this problem with an iterative search? Okay, now immediately there's a question. If I'm taking steps of fixed size, can I improve my algorithm by taking steps of varying size? Maybe there's a better step size I can choose. And can I change my step size in clever ways? Can I take the interval and break it up into chunks? So bisection is a way of splitting the interval every time into half. So if I want to search for numbers from 0 to 100, I check, is it in the interval between 0 and 50 or between 50 and 100? And then 50 and 25. So I can go, in that case, I get tremendous speed up. That method is called the bisection method. So it's there in this page. If you scroll down below, yeah, right there, yeah, just a little bit up. Yeah, I've given the code, but I just want to show what's in the print. Yeah, right there. Improve guess bisection. See, notice that just by changing the improve guess method, just by changing one method, if your code is written well, you can get a completely new solution for finding square roots. And now you see the power of functions. Okay, there's some fiddly bits. If you guys really sit down and write this and try to change your code with one function change, you will see some interesting problems. So if you get that far, please reach out to me. I will share you some deep insights in here. Okay, but the idea is that we can go from a simple iterative search to something that's much more powerful by changing one function. The stopping condition, the while loop, everything remains the same. Just how do I take the next step is different. That's it. Right? And now I want to take you to this other one. So there's a method called the Newton-Raphson method, goes back to Newton. And this allows not only to find square roots, allows to find cube roots, all kinds of things, find even solutions to algebraic equations. But anyway, if you use Newton's method and apply it to this case, he simply says, if I'm at a certain guess, I will take the guess, I will take the number 4, for example, x, which is the number I'm trying to find the square root for, and I'll take an average of guess and x over guess. And if I take this average, I will get to the answer very quickly. Okay, and if you guys write all the code that I've asked you to write and explore this, you'll see Newton's method will be much faster than an iterative search or even a bisection. It becomes a small discussion in mathematics. How did he come up with this? And the answer is he was thinking of a more general problem, and that eventually led to this. I don't think Newton just said, oh, let me just take the average of the guess and x over guess and I will get the answer. Okay, but he had a more elaborate thought process which produced this as an artifact. I spent a few extra minutes here. I could spend a whole lecture on this, but the reason I spent time here is to show you that armed with a simple for or while loop, a mildly interesting problem, we can explore and discover so many things. So right now I've talked about using algorithms, I've talked about solving a mathematical problem, right, etc. So there's very rich, so we are at the tipping point today of getting to very interesting problems. Okay, so so with that said, now let's go to the last part of our class today. So let's go to section 3. There's one more example. This FizzBuzz, I just want to tell you that FizzBuzz is just it was used as a test to see if programmers know how to write code. And at the time this test was first given to people, I think 60% of people couldn't write the code properly, even though they were programmers. So I don't want you guys to be in that group of people. I'm sure you can write it. Just have fun, write it, and see if you have questions, come back. Okay, so let's go to session 3 quickly. Yeah, we'll come back to scope later. It's okay. If you have a minute, read that section on scope. Yeah, there's a bunch of quiz. Okay, so there's quiz. We'll talk about quiz logistics in a minute. But if you go to session 3, so I want to take another 10 minutes. Is that okay? Somebody in chat? Yeah. I am not seeing chat, so okay. So yeah. So let me just go here quickly. Okay, so this is a very important section. I've put some comments in here, but the million-dollar question is, how can I make sure my code is correct? Okay, and the idea, so we will actually write, I'll show you how to test your code and make sure it's correct. So can we quickly take this poll? Should take a second. Yeah, and that's what I expected. Very good. Those who write print statements, very good. And then the next one. So this is an abstract question. It's important. Do you think it's easy to test code and make sure somebody gives you code and says it's doing the right thing? Do you think it's easy or it's hard? Well, it's trying to decide. Okay. So I will just tell you right out of the gate that testing code is hard. Right, and I will make some kind of theorem that says the intelligence to test code must be at least equal to the intelligence that created the code. We'll see if it's true or not. Okay, but there are so many things we have to decide. So anyway, so I just want to give you some ideas around testing. You know, there are different types of testing. So the first one is called black box testing. You pretend that the whole program is a black box. You cannot go inside it. You just send information to the program and observe what comes back and see if the program behaves the way you expect it to. So it's a black box. But you will see very soon that black box testing becomes very hard for you to guess what all to test and won't focus your attention on places where the code is likely to break. So then we do this thing called glass box testing. We pretend that we can read the code, or we read the code, and then we choose tests to look for weakness in the code as written. Clearly, glass box testing is harder because you've got to get into the code to decide what you want to do. Black box testing is nicer. So whenever you have a choice, if you can make the code into a black box test and feel that it's enough, then you're in a very good place. But otherwise you have to do more work. Then the next piece here is automated testing. It is really nice to think that you have an automated machine that runs. Every time you change your code, it automatically checks if your code is broken or is valid. And so you update code, you hit Control S for saving or whatever, and it tells you if your code is broken or not. So automated testing is nice. You can even have it run overnight if it's a very big piece of code. So a lot of companies that produce big code, people finish the work for the end of the day and check in their code at the end, in the evening. When they come in the morning, they get just a big report. It would be really nice if the report tells you exactly where the code is broken, right? Then you can go and fix it and then make progress. And then the last thing is a very key idea I want to stress is if we are focused on tests and tests are hard to write, why not we read the requirements of our code and write the test first? So you write the test first and then you can, as your code is being written, you can make sure you're passing all the tests. Okay, quickly, if you scroll down, some benefits of testing, right? It's very expensive as your code base gets bigger and bigger. Those who have written fairly large projects will see this. As your code gets bigger and bigger, it's hard to find and fix bugs. You better catch things early before life gets complicated. Then I think it's just a good discipline. In the evolution of software development, individuals and teams, at some point you'll realize testing takes a lot of time, and so you will start investing in tools and processes. It's the maturity life cycle thing. Okay. I've given some other comments in there. You can read it, but I want to say today we will write a few lines of code at least, and we'll use this Python unit test framework, and I'll show you how to use it to write a test. Now, the important thing here is in an abstract way, a test is basically saying something is equal to something. Right? So I have an expected value and an answer. Expected value equals answer, then I pass the test. So there's a simple equality, right? And this equality is done by, if you look at the second last line, assert equal. There's a function called assert equal. You pass two values in and it checks if they are equal and lets you know. So I am simplifying the entire discussion of testing today, at least for today's discussion, to say at the end of the day, we have to check that something is equal to something. So if we do that check, then we are good with testing. Okay, so let's switch to the lab quickly. I think, yeah, you can read this. Just switch to the lab. I will show you some code. So for this lab, I want to use a slightly more powerful tool, and I will show you the tool as we go along. So Will, if you scroll down, you just click on the main.py quickly. On the left, main.py. Yeah, so this is a code editor. If you guys really want to save your work and so on, you need to create a login. Okay, so you can do this after the session, Will. For now, we can just type a little bit. This, I have to warn you right now, this thing doesn't automatically save your work. So if you're writing code, get in the habit of saving things periodically. Okay, so what are we seeing here? Important idea. We are going from the world of single files to the world of multiple files. And in particular, I'm taking you to this world because I want to put the tests in a separate file. In fact, in a separate folder. So if you look quickly, you will see that there's a file here called main.test.py. See under the test folder on the left, the files are organized in folders. Yeah, all the way. Yeah, one below. Yeah. So the test files are here and the code files are in the root folder under source, src. So this is a nice style to store your code files. You put them in source folders where the source code is living, and then you put them in test folders. Okay. Now let's get started. So I will, right here, I will introduce you. So quickly, Will, we can make the font one little bit bigger. Maybe if you click the edit, change editor settings. And just put font size 16 maybe. 16 may be big, but okay. Okay, so it's a little bigger so everyone can see. So now I want to say, first of all, a simple idea here, which I think is important. When we work with multiple files, if you want to bring the functionality from another file into the file you're working in, we use this keyword import. It's a very logical thing. It's import. you can see that I've actually specified the path to this file because it's in a different folder. So it's root.source.square root brings all the functionality of the square root file into this folder. But because there are functions, multiple functions in the square root folder, if I put this extra keyword as square root or as t, then all the functions can be accessed by typing square root dot something. Okay, simple idea, importing functionality from different files. Okay, so there's a bunch of imports here. I want to test all the files in the source folder. So all of them have been imported. The last line on line 12 is very important. This is the line that imports the library called unit test into our code. So now we have the power of unit test in our code. Okay, if you wanted, you could have imported unit test as u as well, if you wanted to, and then you can write u dot something. Okay. Now, what I have tried to do for today, for this week, is to show you that writing tests, you can just copy, you can just keep working in this file. You don't need to change anything. What you need to do is write functions. Like, look at this function which says def test asserts. This is just a simple function. Later I'll explain why it has to take this parameter self. That has to do with some object-oriented ideas. So please, for today, I beg indulgence, ignore it. Every time you want to write a new test, you just def a function. So here's the mantra, def a function. It has to start with the word test. Then you can call it anything else after that. And it has to have one parameter called self. So that is the rule for writing tests. And now inside this function, you can write a bunch of assert statements. Preferably only one assert statement per function. Right now I've written multiple asserts to show you that different type of asserts are possible. Okay, so immediately I'm going to tell you, Will, just take off all of the asserts from line 19 to 23 and just delete them. You only need assert equals. Just delete them. That's it. You only need one. Okay, that's all you need to learn. So this test will pass obviously because it asserts that 2 is equal to 2, right? So let's just put triple quotes and comment off the rest, William. No, come below, come outside, line 20. Yeah, put triple quotes. One more. Yeah. Yeah, and then go all the way to the bottom. And then just before that, if on line 41. Yeah, put triple quotes again. Yeah. Okay, so now we have just one test. Let's just quickly hit the run button. I think first time sometimes you hit the run button before you start testing. I'm not sure. No, run. Yeah. Yeah. Now you hit the test button. Don't worry about that. Just hit the test button. And you see that it runs and it says it's fine, right? The test is run and the output is there. Can you scroll down with on the right a little bit? Not that one, Will. All the way back up to top. Yeah, that one. Yeah. So it says ran one test and it tells the test is okay. Now let's go back in and change insert 2 equals 2. Let's assert 2 is 3. Scroll up a little. Yeah, 2 is 3. Okay, just run the test again. No, you have to hit the test button. So I'll explain what run does separately. Can we see the output? So it says assertion error 2 is not equal to 3. So in a very short window, I've given you the keys to the kingdom of testing, right? We have to write this def test something function. And then we have to say assert equals something equals something. And the trick is, what is the assert we have to assert for different programs? Make sense? Now, let me just explain the run button quickly. If you click on main.py, I can write a function here. Same idea. I can import all the code from different files. And in main.py, I can execute them. Okay. So notice I have increased the complexity in your life in one day. I don't expect you to be completely comfortable here. Go home and play with it, and we can do office hours on Monday. So we can spend a lot of time on it. Okay. But it's just that it's multiple files and we have to bring them all into main.py so I can run them. So for example, let's go to this file called testing.py. On the left, testing.py. Yeah. So see, there's a simple function. It's called square. it returns n star n, right? So how can I use this function? So go to main.py. And you see, have we imported it? Yes, testing is imported as T, right? Yeah, so you can just delete off the first two lines in main. No, right here, line 12 and 13. Yeah, just delete them. Good. And now you can just take off that also. Probably 13 also can go. And just do print t dot square. So we'll just execute that function, print t dot square 2. Let's put a bracket. We have to give a parameter, t dot square 2. Okay. So now just hit the run button. So this will run this file. And it gives the value 4. So what have we just done? We have created an infrastructure for us to work with multiple files and to work with testing. But what is most important for me as instructor in your course is you have an assignment to do. When you finish the assignment, if you hit the submit button, it will automatically grade it for you and put the grades in the grade book and so on. Right? So if we are programmers, we should try to automate things and make it work well. By the way, because I like you all so much, I allow you to submit as many times as you want. Some instructors will only allow you to submit twice or once or whatever. I want you to write code and keep trying, okay? But you don't need to hit the submit button all the time, right? You should hit it only once. Use the run and test. So you use the run button if you want to make a program that displays things on the output to you to see. But if you don't need to display anything, work on testing here. So you go to the main.test file and you write tests. I want to pause. Are there any questions quickly? I think this is all I wanted to do for today. Then I have to talk to you about your labs and so on, but I don't see any questions or anything on chat. Anyone? Okay, so then, sorry, I don't see. I'm going to take 1 second just to see if anyone has any questions on chat.
No, there is nothing right now.
Oh, okay. Thank you. Okay, so let me just recap. So you got a quick tour of how to write tests. Even though it's a complicated field, we have just a simple idea to take, which I showed you explicitly how to do. Now, all of you should try to do it. I don't expect you to be completely comfortable. We can spend some time in the labs, in the office hours to discuss anything more. And there is a lab here. Will, can you just quickly share your screen? Okay, I can. Can you share your screen again? I will just show you that quickly. It won't take more than a minute.
Having some trouble logging into the lab. Did you check?
Will is having trouble?
Logging into the lab. So
okay,
he's saying that in chat.
Okay, let me. Yeah, what is the trouble, Will?
Hi, it just seems that, can you hear me?
Yeah.
Yeah, so when I go to the session 3 lab external resource, it says you are not signed in, which is confusing because I'm signed into the ACADS account.
Correct. Thank you for mentioning it. So yes, unfortunately, we don't have a single sign-on.
Okay.
You need to create an account on that. That site is called.
Okay, gotcha.
It is called CodeBoard. You need to create an account if you want to save your code and so on. I suggest you please do that.
All right.
But I want to say that if you click on a file, even though it gives you that message for now, just click on any file. Can you please test that? Click on main.py.
Yes, 1 second.
It will allow you to see.
Okay, yeah, perfect. Yeah,
so it's a mildly distracting thing for you to start. Thank you so much for putting on your microphone and sharing that. This is the world that we live in. You can make it better. But so you can get started. You can click on files, you can execute, you can run, you can submit. But you might want to save your files and do various things. So please create an account.
All right, thank you very much.
Yeah, sure. And I want to repeat, please start the habit of saving periodically. Right? It's especially when you hit submit, you want to see what happened. You'll hit reload. You have to hit reload to see your grades come through. If you hit reload, you lose all your work if you haven't saved it. So I don't want any of you to lose your work, okay? So yeah. So I think we are here. Let's take a minute. So if can you scroll up, Will? Just scroll up a little bit on this page. So here's a little lab for you to do. Okay, the one part of the lab, question 2, we already did in the class. It's that iterative square root. Just transfer it from there, put it here, write some tests. So the test for iterative square root would be pick a number like 9 or 3, and see if it actually calculates the square root correctly. Write tests. The goal here is to write tests, okay? And there's another simple program. You can read it. It's mildly fun. Takes you back to counting on your fingers. See if you can get that program to work as well, right? So 2 small exercises. The code is not difficult. I want you to get used to writing tests. Okay, I've used up a little bit of time. Are there any questions? Otherwise, I can let you guys go. Actually, there is a poll on the end of session 3. Can you get us there? It's probably in the summary section. It's probably just outside. Yeah. Okay, summary. Just click on summary. Okay. So just some quick 1-minute poll, and then we can close the class. So I just want to recap. We covered functions. We covered making decisions with if statements. We talked about loops. We talked about testing code. Lot of ideas. Hopefully the pace is good enough. There's plenty of time in office hours we want to discuss. I think you guys are all hungry for fast pace. Okay, next time we can go to more and more complicated things after this. So quick poll. How comfortable are you with the material discussed so far? Okay, that's a good one. Okay, most of you, that's what I expected. Most of you need a little time to practice. Hopefully this is interesting. I didn't ask the question, are these interesting things? Hopefully this is interesting. I'm trying to give you something that is a little bit fun, but also you're learning very powerful tools which will be helpful in your career as programmers, how to write tests and so on. We will not get it in the first pass, but that's okay. We will discuss it more and use it more. From now on, by the way, all our a bulk of every session, we will do one assignment like this, one lab like this. We will write programs, we will test them, we will submit them, blah, blah, blah. Right? So hopefully that will be more interesting, certainly more interesting for me, I'm sure for you. But I don't want to hold you guys any longer. You're a great class. I just wish you would bother me with more questions. But also don't hesitate to reach out to me, send me email with anything. I'm here to help. Enjoy your weekend and stay warm. Thank you so much. And thank you, Will, for typing during the session. Much appreciated. Thank you all. Have a great weekend. Yeah, send me email if there's anything I can do.
Thank you.
Thank you, Amay. Thank you, Amay.